project Spectral Light is about the design of the light, because we think that today the most important thing is the design of the electromagnetic wavelengths that compose the spectrum of the light, and maybe less the design of the object. And why we think that? Because the design of the electromagnetic rays that compose the spectrum, we have to decide which they are, because, for example, the incandescent lighting of before or the halogen, it's emit a lot of wavelengths out of the visible spectrum, so it means a lot of infrared was emitted, and it was like losing money, losing energy, and be like emitting green gas effect, you know. So it's mean that we have to reduce the range in order to stay inside the visible, and in order to be in an ecological vision of the light, and not to participate to the global warming. So this is the first reason why we have to select the wavelengths that compose the spectrum of the light. So the second reason is a question of health and biology, because if we emit light, we have to think which will be the wavelengths, and we know since 20 years that depending on the different wavelengths, you have an effect on the body. And for example, there is one wavelength that could block the melatonin. It's one hormone, and so it will be better to have this for the light, because if you don't have this wavelength, so it means you will produce melatonin, and so you are like sleepy, and you could create some disorder. And the same thing is about the cone, because inside the eye we perceive the colors through 3 cones. And these 3 cones have a specific wavelength receptor. So it means if you emit the light not in this range of the wavelengths, you will create some disease, because the brain could not perceive the real color, and so you have to invent, and so it creates some disorder, and you have headache, and you could have insomnia. So this is the reason why fluorescent lighting, for example, like 20 years ago, creates some disease for the people that will live with this type of lighting. So it means that the choice of the wavelengths is today very important through ecological point of view and a biological point of view. And there is another reason, is the LED system, because LED is made of semiconductor light. So semiconductor is when it's stimulated by electricity, so it creates one peak of wavelengths. So it's not a full range of full spectrum. It's a single light, single wavelengths. And so for creating the light, you need to have an addition of different semiconductors that will produce different wavelengths. So it means that according to this technique of LED, you have to be a little like a perfumer, or like a chef. When you cook, you have to choose ingredient and to compose something with this, like an addition of different ingredients. And so for this lamp, what we propose is to choose the different ingredients, the different wavelength according to the human eyes. So we choose like 3 cone emitting light that could be perceived by the 3 cone, and also the one that is perceived by the melatonin, by the pineal gland inside the brain. And we compose like with these 4 peak, with these 4 wavelengths, we compose a kind of human light. But then we say we are not alone in the world, we are not alone in the house, so there is also the plant, there is also birds, or there is also dog and hamster. So we propose to have different, to do a lamp, because each animals have another way of perceive the world. So for example, here we are this is a plant range of perceiving the light. So it means you could see that there is no green here, because the green is the color of the leaf of the green plant, because it reflects this, it doesn't absorb. But for chlorophyll, for the photosynthesis, you need some red and blue and violet. This is what the chlorophyll absorbs, and through that it creates the plant grow, and it creates the photosynthesis effect by changing the CO2 into carbon. And so this is like the good light for the plant. So these wavelengths all together are the good light for the plant. And then we have another here. This is a good light for the dog, and this is a good light for the human, and this is a good light for the hamster, and this is a good light there, the good wavelengths for the birds. So in our product, in our final product, we propose to add all this together, and then you could decide with your with the computer, you could turn on or turn off some lighting. For example, if you are there with a dog, you and a dog, you could have only the dog and the human light, and if you go out of the house, you could turn off all the dog and the human and keep only for the green plant, for example. So this is like how to be economic, how to fight the global warming, how to not emit a lot of wavelengths that doesn't you don't need them. So it's like to find a kind of synthesis between ecological point of view, biological point of view, and the new technique of LED. So this is what we are doing with this spectral light.